Hello everybody. In this video we will learn about exponents with integer bases and what it means and how this whole thing works. Couple things. One, the base is the big number right there. That's what we call base. The exponents is the little number that goes on top of the big number. So the base and the exponent. Now, the exponent tells us how many times the base is used as a factor. What does that mean? Well, so 5 to the third power means 5 repeats itself 3 times. So it's the same thing as 5 times 5 times 5. That's what it means. That's what this whole thing is trying to tell you. Okay? Now, when we have a negative in this scenario versus this scenario, what is the difference? And what does that mean? So I'm going to expand before I'll show you in the calculator how you can just put it all in. So first, what does that mean? Well, that means negative 3 repeats itself 4 times. So negative 3 times itself 4 times. 1, 2, 3, 4. Okay? And then you can evaluate that either by hand or just plug it all in the calculator. So I know every 2 of these guys, that gives me 9, positive 9, because 2 negatives make a positive. So between these 2, I have 9. Between these 2, I have 9. And then everybody knows 9 times 9 is 81. Oh, voila. So this whole thing, after I expand, I know what it really means. I know now what it looks like. And I can just simply say, okay, negative 3 raised to the 4th power is 81. Well, but if you have a handy-dandy calculator, you can just plug it in. Yeah, you can. It will give you the same 81 that you had right there. Okay? Either way. But be careful with parentheses right there. Because this question has parentheses. This question does not. So what is the difference? Well, the difference is this exponent is only raising the 3 to the 4th power. Notice that negative is not being raised to the 4th power. So that means this negative is just really negative 1. And 3 repeats itself 4 times. So 3, 3, 3, 3. 1, 2, 3, 4. Okay? Now, I already know this whole thing equals 81, but negative 81, because we already did all the math over here. Because 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. And if you put that in the calculator, negative 3 to the 4th power, you get the negative 81. Okay? So be careful if you're just using the calculator. And if it gives you an answer that doesn't make sense, go ahead and check. You probably didn't put it in right. Okay? But just make sure that when you're evaluating these things, it makes sense when you work it out. Another one. So when you have the negative on the outside, you know that negative is just a negative 1. And then the 9 repeats itself 3 times. Okay? So it's going to be negative something. 9 times 9 is 81. 81 times 9, 700 something. Right there. You can see. Right there. 729. Okay? Okay. Now, negative 13 raised to the 0th power. From previous videos, you remember that anything raised to the power of 0 equals 1. Bananas raised to the power of 0 equals 1. X raised to the power of 0 equals 1. Anything. So write it out. Anything raised to the power of 0 is 1. The power of 0. It sounded better in my head. Okay, last one. So, what is this asking? What number do I raise 7 to? What power is 7 raised to that gives me 2,401? Well, I don't know. So, we're going to find out. So 7 to the 0th power is 1, so we're going to skip that. So 7 to the power of 1 is 7. 7 squared, 49. So I'm trying to find numbers right here for x, okay? So when x is 2, I get 49 there, so it's not 2. So 7 to the 3rd power, is it 343? 7 to the 3rd power. I don't even know what I said, 343. So 343 is still not it. So 7 to the 4th power. Voila! So 7 to the 4th power, that gives you 2,401. So what is the question? What is my answer? Well, the question was, what number do I put in for x that makes this equation true? So what is the power of 7 that gives you that 2,401? Well, x equals 4. Because if I raise 7 to the 4th power, that gives you the 2,401. Bye.